Hey everyone, hope you're doing well and thanks for watching today's video where we're going to talk about an introduction to trigonometry. So you may have heard of trigonometry, you may have done it before, but just so you know, the definition of trigonometry really is triangle measure. So that's what we use trigonometry to do. We use it to find measures of triangles. It can be side lengths or it can be angle measurements. And so that's what we said when we use trigonometric ratios to help us find lengths or angle measurements. And note the following only apply to right triangles. These rules only apply to right triangles. This is really important, something that you've got to remember because we'll have other ways to solve for triangles that aren't right, but these rules are only right triangles, only apply to right triangles. And the best way, well, let's go through them now. Only apply to right triangles. So we're going to start with sine, and that equals the opposite over the hypotenuse. And let's just draw our triangle just so we have an idea of what we're talking about here. So it says sine of theta. That's this symbol. That's that kind of like a zero with a little squiggly line through it. That's theta. So sine of theta equals opposite over hypotenuse. And these refer to sides. So when I say opposite, I mean the opposite side. Hypotenuse is obviously the longest side or the side opposite the right angle. So let's consider that this is theta. So what we're doing when we do this sine of theta, we're taking sine of the angle measurement. So theta is an angle measurement. Let me make this a little bigger. And we have these things called reference angles, and that's where we are like for the triangle, because if we're at two different angles, they're going to have two different opposite sides. But let's consider this situation first. So we have theta here. This is obviously the right angle. If I'm taking the sine, I need to do the opposite side over the hypotenuse. Well, let's think, what does it mean by opposite side? That's the side opposite the angle. So that's going to be this side here. So let's say this was 10, and let's say this was 15. So my sine of theta, so sine theta equals 10 divided by 15 because that's the opposite side over the hypotenuse, 10 over 15. So now let's think about, well, what about cosine? That is adjacent over hypotenuse, and adjacent you can think of as really the third side that's not opposite and it's not the hypotenuse. Well, for us, that must be the side right at the bottom here. This is the adjacent side. So then let's say that equaled, I don't know, 7 or something. So then cosine of theta would equal 7 divided by 15. Note that the 7, 10, 15 is not a perfect triangle, so it wouldn't work, but I'm just doing some examples here. So let's erase these. And then now we have the last one, which is tangent. That's just opposite over adjacent. So that's going to be opposite again would be 10. Adjacent was 7. So tangent of theta would be 10 over 7. And these are the angle measurements. So if tangent equaled something, we would plug that in. So we would say, well, tangent equals 10 over 7, and we could use that to help us solve for the angle measurement theta. And we'll get into that in the next video. But here I just want to give an introduction to what trigonometry is. And so the way to remember these is Sohcahtoa. So Sohcahtoa. I learned this when I took geometry first, and I still remember it today. It's a great way to remember the ratios, because these can be confusing at first. So first we have sine. Each of these stand for a letter. So sine is opposite over hypotenuse. We've got cosine is adjacent over hypotenuse. Then we've got tangent is opposite over adjacent. So those are the ways to remember it. Sohcahtoa. So just memorize this thing right here, and you should be able to reason out what the ratios are. And that'll help us solve for the other triangles. So here we talked about the reference angle being at the bottom right-hand side. Well, what if we had the reference angle up here? The reference angle is just what theta is representing. So if theta was in the top left, well, that's actually going to change everything. And that's an interesting thing about trig is now the opposite side is different, right? Because now the opposite side is this, and the adjacent side is this one. So now this would be adjacent, and this would be opposite. So all those ratios that we just talked about are going to be different because our reference angle is different. So let's just look at an example here, and notice that the hypotenuse will always be the same. The hypotenuse is always the side opposite the right angle, no matter where our reference angle is. Okay, so find the three trigonometric ratios for this triangle here. And notice that it is a right triangle. We couldn't do it if it wasnthe trigonometric ratios only work for right triangles. And I'm going to write Sohcahtoa because that's what helps me remember it. So Sohcahtoa, because I'm going to need all of those here because it wants me to find all three trigonometric ratios. And we're going to do it for this angle first. So where that is theta. That's an important part. We have to know what reference angle we're referring to. Okay. I'm going to call that, this one would be theta. So sine is opposite over hypotenuse. So I'm going to say sine of theta equals, well, I know it's going to equal the opposite, but wait, I don't know what the opposite is. So I need to somehow find this, right? How can I find the opposite side length? The Pythagorean theorem. So a lot of things coming together for this unit, hopefully. A squared plus b squared equals c squared. A squared can be the 5 squared plus b squared, we don't know, equals c squared is 13 squared. Remember, this is a Pythagorean triple. We talked about that in one of our videos. Hopefully you remember that. I'm going to subtract 25, get b squared equals 144. So b equals 12. And if you knew the triple 5, 12, 13, you might have seen that right away. So this is 12. Okay, so sine is opposite over hypotenuse. That's going to be 12 divided by 13. Cosine is adjacent over hypotenuse. So cosine of theta equals 5 divided by 13. And finally, our tangent of theta is TOA, which is opposite over adjacent, is 12 divided by 5. So those are our three ratios for this angle. And now let's name this one. Let's just make this angle x. And now let's find the trigonometric ratios for that. So this is x. So now we would have sine of x. And sometimes you can put the variable in parentheses. It's a common thing with trigonometry. So sine of theta, of x I mean, would be 5 over 13. Notice that now this side is the opposite. So let me erase the opposite here. Now this side is opposite x. It's the side on the complete other side. So that in this case is the 5. So cosine of x, well now we need the adjacent of x. Well, that's going to be that third side. So it's not opposite and it's not the hypotenuse. In that case we have the 12 divided by the hypotenuse of 13. And then finally we have tangent of x is going to be opposite over adjacent, which is 5 divided by 12. So those are our three trigonometric ratios for x. So hopefully this is making a little bit of sense. We'll get into some more practical problems in the next one where we're actually solving for the triangle measurements here. And so hopefully you understand this and really memorize Sohcahtoa. That's the key to this and just the key to being able to solve these quickly. And also know this right here, it only applies to right triangles. Really important. Okay, so thanks for watching and don't hesitate if you have any questions.